Good morning. Happy Saturday. I almost said happy Friday, but it's Saturday. I'm a little tired, man. Almost thought about not streaming at 5. Almost delayed it by an hour, but I was up. Here we are. I've got a coffee freshly brewed. Hoping that'll wake me up a bit. Yeah. Gee, Merry Christmas. Merry Christmas Eve for me. It's not Christmas just yet. But happy Christmas, my friend. Yeah, we're gonna look at this puzzle here. I am looking forward to having all these puzzles done and not having to not stress, but think so hard in the morning. Yeah, the puzzle had gotten kind of difficult. Good. Well, people have told me that, and then I spent, 4 hours solving a puzzle, so we'll see. But it's a good sign. It's also a good sign. Yeah, definitely want to get out before groceries close for sure. If you need to get some groceries. Day 24. I'm amazed I've managed to keep going with this every day. You guys have kept me motivated to do it though. It's been super fun. I didn't expect when I started streaming. I wasn't really expecting it. I was gonna stream until my school year was over, but it's been addictive streaming with all of you fun people. You and Smab and Keith and Formal Goose, all of you guys. What am I doing? .NET, new solution. Well, that's... I think I love this type of stuff, but every day starts wearing you down. When all I want to do is, not all I want to do, but, part of me, I'm on vacation too. That's the other thing. I'm technically on vacation, so I don't want to just, and I'll be taking several days here off, out of town, 28th through the 3rd or 4th, I think. So I'll get a nice vacation then. All right, we got a workspace set up. Let's read this. But yeah, we're at 46 stars, man. That's exciting. We're about to save Christmas. All right, as soon as I click yes, it's gonna do something on me. There we go. With everything replanted, let me make this a little bigger. With everything replanted for next year, and with elephants and monkeys to tend the grove, you and the elves leave for the extraction point. Partway up the mountain that shields the grove is a flat, open area that serves as the extraction point. It's a bit of a climb, but nothing the expedition can't handle. At least, that would normally be true. Now that the mountain is covered in snow, things have become more difficult than the elves are used to. As the expedition reaches a valley that must be traversed to reach the extraction site, you find that strong, turbulent winds are pushing small blizzards of snow and sharp ice around the valley. It's a good thing everyone's packed warm clothes. To make it across safely, you'll need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance to the valley. So you make a map of the valley and the blizzards. For example, the walls of the valley are drawn with hashes. Everything else is ground, clear ground. Where there is currently no blizzard is drawn as a dot. Otherwise, blizzards are drawn with an arrow indicating the direction of motion, up, down, left, right. The above map includes 2 blizzards, one moving right and one moving down in 1 minute. Each blizzard moves 1 position in the direction it is pointing. Due to conservation of blizzard energy, as a blizzard reaches the wall of the valley, a new blizzard forms on the opposite side of the valley, moving in the same direction. After 1 minute, the bottom downward moving blizzard has been replaced with a new downward moving blizzard at the top of the valley. Okay. So we have a map. Blizzards can blow. Okay, so when it goes off, it comes here. Okay. Is a blizzard allowed to go to one of these 2 spots? I wonder. Because the blizzard are made of tiny snowflakes, they pass right through each other. After another minute, both blizzards simply occupy the same position marked 2. After another minute, the situation resolves itself, giving each blizzard back its personal space. Finally, after yet another minute... Have you ever hovered on those words? Yeah, they go to, like, Wiki... Oh, these ones? Energy... Oh, wow, that's hilarious. There's been a lot that's really funny. Oh, man. This process repeats at least as long as you're observing it, but probably forever. Here's a more complex example. For expedition, gains in the only... excuse me. Non-wall position in the top row and needs to reach the only non-wall position in the bottom row. On each minute, you can move up, down, left, or right, or you can wait in place. You and the blizzards act simultaneously. You cannot share position with a blizzard. In the above example, the fastest way to reach your goal requires 18 steps. Drawing the positions of the expedition E. One way to achieve this is down. All right, we're doing breadth first search, I think. The moving blizzards make it at least a 3-dimensional puzzle, like 3-dimensional map. We can probably solve it without actually generating all possible like map locations. How big is my puzzle input? And if my puzzle's a square, then my 3rd dimension is just time that repeats every, dimension size. It looks like it's not a square though, so we got a new file input.txt. It's hard to tell sometimes though. Oh, this is definitely not a square. New file example.txt. Example. Yeah. Well, we have positions. Oh, my brain is mushy today. Smab, happy Saturday, my friend. We're almost there. Merry Christmas Eve. Part of me doesn't want to do this puzzle. An int row and int column, and we have northeast, southwest. I've written this code 90 times at this point. With I should really have some should really write some helper classes here so I don't have to keep rewriting this to, you know, orthogonal position. Oh, I can already feel my brain mushing around and it's in my skull. Not wanting to not, all right, we gotta focus. We gotta focus. We're gonna do it. It's gonna be okay. Our map changes, or at least we have blizzards inside of it that move their position. Yeah, this one's it's a 3D puzzle, and there's where you are. Part of me is like, I bet I could do this one with a Monte Carlo simulation as well. Part of me is going, that might be easier. I think breadth first search is just the way to go, though. And don't worry about going back into a position you visited before, I think. Or have the position somehow be like the state. Like you need a third dimension that's the state. I think we just do breadth first search and we don't mark where we've visited. And we just like keep going out until we reach the end, and then you stop as soon as you reach an end. I'm gonna try that, and then, well, maybe I'll put in the state. It's just the state is kind of big. Yeah, that's why I was sort of, you know, I wish this was a square, because then I could just use a number to represent the cycle. But I guess I could use a number to represent the cycle of the, what would be the, if it's divisible by each other. So if it's, yeah, anyway. My brain is just like not working to this morning. I'm already feeling it. We'll create a board. And then luckily, it seems that we always start in the top left and bottom right. So the exit is essentially here and here. Yeah, okay, cool. Good to know. Good to know I don't have to be clever. All right, so we got a board, public record board. Really, I don't want to have to redraw the board every time. I just need to keep track of what positions I can and can't move into. So it's like a hash. Need a list that can be turned into a hash set of positions. Just go around the walls. Yeah, I think I need to, so they can occupy the same space. So I need like a list of like blizzards, and a blizzard has a position. All right, we're gonna try not to be too efficient. We're gonna, because maybe we don't care enough for it to be efficient. Like our board state changes every step. It's gross. I hate it. All right, so let's create a blizzard record. Blizzard. Public record blizzard, and it has a position P and a like function that gives it the next position. Next position. And then we will return. We have a function called public blizzard next, which just does return next position from position. With there we go. All right, so now we can update our blizzard. Oh no, I was gonna say I was kind of thinking of doing a Monte Carlo on this one, Smab. Oh, that's too bad. I was like, that'd be fun. So if you do Monte Carlo, but you really favor going south and east, you're like, oh, if you can go south, if you can go east, do it. But I guess that's because obviously there's gonna be a path where you have to like go up and back over. Okay. So when we build up our... Alright, so we have a blizzard. I want to override public override get hash code is just going to be position public override bool equal. Is there an equals? There we go. That's what I want to do. They're equal if their position is equal. So I think kind of what I want to do. Maybe I'm dumb. All right, we're not gonna do that. I was thinking. All right, I'm trying not to do anything stupid. We're gonna keep just doing normal. Brute force this. We're not gonna do anything crazy. I was thinking of efficiency. Maybe I can make a blizzard be equal to its position, and I can have a hash set of the positions. But I still need a list of them. But I could have for fast lookup. I could have a dictionary from position to list of blizzard, and then my key set. All right. Anyway, public record board is a list of blizzards, and int width, and an int height. Height? Is that how you spell height? Why does that look so weird to me? Because it is wrong. That looks weird too. H-E-I. Do you mean height? Oh. Whew. Too early, man. Okay. All right, G. I'm trusting you. Static board. Parse. Okay. Parse string rows int width is equal to rows dot length. Length. My height, int height is equal to rows dot length. Memory usage wise, it's low if you got the right idea. Well, you know, we'll see if I have the right idea. List of Blizzard B Blizzards return new board. Blizzard with so just for me, I'm gonna give Blizzard a care as well. Care ch. Because I'm gonna use I'm gonna make the walls blizzards too. That walls that just don't move. Oh yeah, man, some of those took up some gnarly space. Public. We'll just call this symbol. For int r equals 0, r less than rows dot length, r plus plus, or int c equals 0, c less than rows of length, c plus plus. Char ch is equal to rows row column, and we're gonna say if ch is a dot, continue, else if we'll do get blizzard public static blizzard parse char ch int width int height. Return ch switch hash new blizzard. Ooh, I need a position p then we just have an ID function. P goes to P, and the symbol is CH. My computer specs is very low. When I tried installing Unity some years ago, the default C# editor was so slow I had to uninstall Unity afterwards. Godot had much lower requirements. Yeah, Godot's actually really cool too. I wish it was more similar to Unity so that it was easier to like transition students to and from it. I have students who use Godot as well. Godot, and also Godot now has a C# binary or assembly, so you can actually do it with you can, rather than using their Godot language, there is you can code in C#, and I think it's the latest version. It uses mono, so I think at least C# 6. This direction is going to be a new blizzard p goes to p dot east, and then we're gonna add in a method called wrap width height ch. All right, let's go into position, and we're gonna add in a wrap public position wrap and width and height. If row greater than or equal to 0 and row less than height and row column greater than or equal to 0 and column less than height width, return this. Otherwise we wrap it, return this with row equals row mod height column equals column mod width. Okay. Yeah. So I debated whether or not I wanted to do a Godot class instead of a C# class, Unity class. Part of me really likes promoting open source stuff, and I believe Godot is fully open source. But Unity, it'd be nice to have my students using Godot, but Unity is another thing. Is Unity is kind of like a quote unquote, I wouldn't say industry standard, but it's kind of an industry standard at this point, where if you want to go into like game dev, yeah. This is probably dumb. I should probably write some local functions. Region, local. Position east p dot e dot wrap with east, west, north, south, west, north, south. This wrap isn't gonna work on the negative side of things. Ooh, man, my brain is just not working quite right. Because if row is negative, I need to do row plus height. And that's not quite right, because if row is like super negative, but this will work for our purposes, I believe. So this is gonna wrap it if it goes negative or positive. And I need to I'm about to write a stupid bug here. Because when it goes here, it wraps around immediately. So it's almost like I need to just use the inside grid here. Ignore the topmost and bottommost is what I'm gonna do. So I'm actually gonna have I'm actually only gonna parse in this middle grid here. And we'll say we start here, and then we'll have like some special cases for those, I think. So in fact, this should just throw an exception saying throw new exception, found wall in middle. All right, and this is gonna be Yeah, absolutely. My brain is so fried right now. I'm probably gonna have to write, not gonna, but I should write plenty of tests just because I can feel my brain sloshing. You ever feel your brain slosh around in your skull? Throw new exception. Found unknown entity. Yeah, very, very easy to have off by one. So my loop here, I want to increase everything by 1. -1. Do I need to do -2? Shifting over 1. I think I need to do -2, but we're about to find out. So I'm chopping off the leftmost and the top and bottom and left and right. So I think I'm gonna do -2 here. Try to 2-string for our blizzard. Public, or for our board. Public override string. String builder B. Let's bring this in. 2-string dot trim end. Ooh, and our width and our height have changed. So our width is now -2, -2. Yeah, we can do this for height. Width. So we should draw out our top row here. So the initial top. To make my wrapping easier, I don't want to have to. I guess it doesn't matter. I want these to wrap around. When I get here, the blizzard just wraps to the end. Whereas before, like my wrap, I had to do. Maybe I shouldn't. Hang on. You're probably right. I just gotta make my wrap wrap 1 before the end. So I was basically gonna create 2 special nodes in my graph that are like the bottom and the top. And then the inside part, so when your blizzard gets to the edge of this board, it doesn't occupy this space, it jumps to the end here. So it's just like making my mod logic a little bit easier. And then I add some complexity somewhere else. I want to be able to mod like this. But maybe that's dumb. So the way my blizzards wrap around the edges, I probably should just change. I don't know if it really does make it that more complex to think about. But let's not do it. Here, let's not do it. Let's not chop off the edge, and we'll just make our wrap be smart. But we'll make our wrap more complex in favor of not chopping that off. I think that's fine. And then when we get a wall here, so this is what I was gonna say. I was gonna say a wall happens to be a blizzard that doesn't move. So we have like a wall. So then I don't have to have logic thinking about boundaries in that regard. And then my wrap is a little bit, so I have to make my wrap say, oh, well, if I'm greater than or equal to 1, I wrap, right? So in less than or height minus 1. So this is like the difference here, is now my wrap function. I'm going to not use mod because it's going to hurt my brain to use mod, but we'll just say if oh, I didn't even think about that. That makes sense though. Yeah, that makes sense. I didn't even think about that. That would have been a nightmare to deal with. But yeah, I'm just gonna make my wrap a smart wrap. If row equals 1, so we'll do new int new row is equal to row greater, if row equals 1, we're gonna be our height minus 1, otherwise row, and then new row is gonna be new row is equal to height. Then we're gonna do 1, otherwise we do new row. Int new column is equal to 1, width minus 1 column, new column equals new column is equal to width 1 new column. And then we'll just return new position, new row, new column. Okay. So this feels dumb, but my brain, for whatever reason, can't think this morning. So we're gonna do this as a dumb wrap. We're gonna simulate it here in a second. Yeah. All right, but we have our walls are just blizzards that don't move. Well, and I was about to write my 2-string here, which was just going to, I was gonna draw a border and then fill it in. But now we don't have to. So now we can say for int row equals 0, row less than height, row plus plus, for int column equals 0, column less than width, column plus plus. I need a nice way to get like where my blizzards are. So I was thinking of doing this thing here. So I'm gonna have a public dictionary, and this is probably dumb too. Position to list of blizzards. All right, this is probably dumb. But given our state, we can say how many blizzards are in a single spot, and then we have a quick way to ask. Yeah, exactly. Walls. This is sort of what this thing is. And maybe I should have this be a hash set. But now in my visualization, I can put how many are in that position if there happens to be more than one. And this is going to be a get. That's going to be dictionary position list of blizzard walls equals new. Return wall at the end, and we got to loop through all of our like this. This is where the inefficiency, I feel like, is going to come from later when we're doing like our walk. Because we keep having to build this thing, so we have to go through all of our blizzards every time to figure out which positions we can move to. And there's probably some efficiency trick I could do there, but I don't know. But I'm not sure. I think we have to update all of our blizzards no matter what, so I don't know that there is an efficiency. And we'll say if wall dot contains key b dot position. So if it doesn't contain this, wall at b dot position is equal to a new list. And then we'll do wall at b dot position dot add b. Right, so now we have our walls. And here, rather than, we need to make sure we don't call this over and over. We need to sort of pre-compute it. So it might make sense to have it memoized like this. And then here we'll say if walls is null, we'll go ahead and compute it. It's guaranteed if wall is null. Updates here. It's guaranteed to not be null here, because we'll have initialized it like that. Okay, so now this will be a quick grab on it, so you don't have to compute it every time. Which might, maybe I do want it to just have a thing where I call compute walls and give it a list of blizzards, but my idea is every state, I'm just gonna make a new copy. I'm gonna have a step and it's gonna make a new copy of my board. Okay, so now we can say if walls, let's make a position p equals new position. If walls dot contains, or we'll do if walls dot try get value p out lists blizzards else b dot append a dot and blizzards not equal null. Is that how we do that? What is this complaining about? I can never quite figure out what this wants me to do. I always forget. Oh, it just wants me to put a question mark here. Yeah. And blizzards is not equal to null. Then we do if blizzards dot count greater than 1, b dot append can we have, at most it'll be 4, so we'll do blizzards dot count and here's I'm gonna char string ch is equal to blizzards.count greater than 1, blizzards.count, otherwise blizzards at 0 dot symbol, and it's going to tell me that that's a character. So I gotta dot toString. Does that count? Dot toString. Ugh. B dot append ch. All right, I think this will draw our board out. So let's do a little test here. We'll parse in some input, string rows equals file dot read all lines example, board b equals board dot parse rows console dot write line b. Ooh, got the hiccups. Guess this project is this puzzle's scaring me, giving me the hiccups. Blitz, just saw your message on YouTube. I hope you have a great day too. Thank you. Line 34. I guess if walls. I'm walls is null. I don't understand how walls is null. Oh, this is how walls is null. There we go. Okay. Says creating a thing. That wasn't it. Okay. Something's clearly wrong, but b dot append a new line here. So now at least I should probably get the right height. All right. I'm not parsing my blizzards correctly. Oh, brain. All right, what is happening here? For each blizzard. How many? Fascinating. B dot blizzards dot count. How many blizzards do we got in there? 0. All right, well, my parse is. I probably never called my function to actually. When I parse, yeah, I just never actually called parse blizzard. Parse ch new position row column width height. Blizzards dot add. There we go. That looks better. That looks much better. Let's do our, let's see, do they have, I do kind of show that. Let's create a really simple example. Simple just so I can see these things wrapping around. I want to make sure they wrap properly. Simple. I also want to make sure that they can like overlap with each other, but that seems like not too bad. Not too bad. Okay. Let's I want to make sure, yeah, I'm gonna use that next too, but I want to make sure my wrap works in all of the directions as well. That one, it doesn't wrap in all of the directions. You're right though, I should use that one as well, just to make sure. All right, so now I want to add in a step, public board step. Step is going to basically update all of my Blizzard elements. So we're gonna have a new list of blizzards. New. And then we're just gonna go through every Steshormara, thank you so much for the raid. Welcome aboard. Welcome aboard. Welcome to Captain Coder's attempts at solving some puzzles. Welcome, welcome. Thank you for that. Fascinating. I don't know how I'm pretty new to Twitch, but thank you. Welcome everyone. We are attempting to solve some puzzles here. Advent of Code, day 24. Yeah, so if you haven't seen the Advent of Code, go check it out. We're working on this puzzle here. Right now we're trying to get a little simulation for our Blizzard. New board with our new Blizzards and the same width. We are in C#. We're doing C# for Advent of Code here. Such a real programmer here. Yeah, so this is fun. I've managed to solve them all so far, so I'm hoping day 24 doesn't hit me. Yeah. Sesh, what language do you use, if you don't mind me asking? This with blizzards equals blizzards. And we're just gonna build this up. So we're gonna say for each blizzard. Ooh, using sed. So that's hardcore. That's hardcore. That is way hardcore. Jeez. So I almost would say that, you know, compared to using sed, I'm like the lame programmer. That's amazing. That's more hardcore than me. All right. When I'm doing some DevOps stuff, I definitely use sed and awk and all those fun things. I could probably do a lot of this in awk. I definitely sed seems like crazy. I might be able to do some of these in awk. I've worked with awk quite a bit. Sed as well, or I guess I should say if I did it in bash, I'd be okay, but it would hurt my brain to try and make things continue working here. All right, so we're about to simulate this. And Sesh, you did the entire. Have you done all of the puzzles in sed? Because then I would have to, like, you know, not worthy. Okay, days 1 through 4. Gotcha. Gotcha. I was about to say if you could do like day 19, cool, cool. That's awesome. That's awesome. Um, console.clear. We're just gonna see here if we can b equals b dot step. Oh, I gotta put this out here. We're just checking here to see if our board seems to update properly. Do these wrap around? No. Nope, they don't. What the heck is happening? Hang on. Clearly my wrap is broken. But let's see if they work if I'm not at the edge. So I have them all at the boundary. So I want to see if they work when they're not at the boundary. No, what's going on here? Position n equals b dot next. And then this should be a blizzard. And we'll do add n. And I want to print out if n dot symbol is not equal to hash. Console.writeLine b moves to n. Over on YouTube, we got This Old Stoner. Happy morning. Formal Goose signing on. I'm trying to resolve a UI blocking issue. Good for you. Okay. And my positions toString needs to exist. I really should be using utilities. Yikes. Public string, public override, string toString. Position, row, call. Let us get rid of this clear. Chandu, are you doing day 24? Make our blizzard toString public override string. I don't know that depth first search is a great idea on this one because you'd have to make all possible states ahead of time. If you do breadth first search, you can generate the states as you go. Oh, okay, gotcha. Not even related to this one. Oh yeah, send it to me. I love coding game stuff. In fact, I have several coding game. I wouldn't call them stores. I like the Clash of Code, and I would like to do more YouTube tutorial videos over on Clash of Code. Sorry, on coding game. I did one like a couple months ago on my YouTube channel. But yeah, I really like coding game. I think they're one of the best gamified versions. All challenge. Really cool. I'm gonna try and stay focused on my thing here, but I definitely want to take a look at it. I'm definitely writing my code very slow, Christy. I can barely, streaming and coding at the same time. You get nice and distracted. Blizzard at position. Here, we're just gonna do this. Position row. Position dot call. And then our symbol. Okay, so this will hopefully help us out a little bit. I did, I don't know if I think I did the spring or summer challenge one where you implement essentially like a binary language. All right. And yet we didn't update. All right, so it does have the correct updates here. And of course I spelled blizzard as lizard. All right, Formal. Have a beautiful, beautiful day. Christy, thank you so much for the follow. I appreciate it. We are struggling here. We're struggling. It's too early. I just ran out of coffee. It's 6 a.m. here. I've been going since 5 a.m. Yeah, Formal Goose. Good luck with your UI stuff. Keep me updated. Keep me updated. I should be back on this afternoon to work on Space Raiders. I know I usually try. Yeah, Christy, that's right. I usually try to finish part 1, then get my second cup of coffee, but we may have to go for a second cup of coffee now. Part 1 usually doesn't take me so long, but I just, my brain cannot figure out what's going on here. Gee, have a beautiful day. Good luck with your shopping. Good luck with your shopping. I hope you get in there before it gets overcrowded. Is my 2-string just not updating well? That's so fascinating that my Blizzard, my 2-string. My board. Oh, I really thought it's because I've memoized this. I really thought when I made a new one. All right, it's because I've memoized this. Which is so crazy. It's like copying it over. And I need wall to equal null. That's why. That memoization got me. All right, so, and my wrap definitely isn't working right either. All right, my number printing is working properly though. All right, let's try again. Yeah, this feels dumb to me, but that's okay. What is going on with my wrap? Topologist, so nice to see you this morning. Why is my wrap? That's how I'm feeling, Topologist. I have AOC burnout for sure. I was saying earlier, man, I cannot wait till the 26th. And I have no obligation to keep going. All right, so the error seems to be on all of them reaching it. I have like an off by 1 on my edge. Width -2. Width and height -2. Greater than 1. Let's see if that fixed it. I know, man. I wasn't even really planning on What? Now I really botched it. I'm so confused as why my wrap is not working. What am I doing wrong? All right, so we're saying there's only one part tomorrow. That's interesting. This is my first advent of code, so I don't even really know what to expect. I'm not. I definitely am setting it incorrectly. There you go. There you go. Set it to 2. And this needs to be width -1. This needs a height -1. Jeez, why is my brain fog? This one should be 0. Get set to width -2. Yeah. Not quite. This one jumped incorrectly. So when I wrapped around on the right side, so my column should go to 1. There we go. Oh, what a painful experience I'm having here. Okay. All right. Now it's working. All right, so my Blizzard simulation works. See, G convinced me to I was originally just gonna have a map that was this inside part and have an extra node attached here and here, but G convinced me to keep it all in there, so I went ahead and did that. Okay, Dota, we're almost there. But I have my steps set up, so now my board will update properly, and now I can finally write a solver to do my breadth first search. Here, so solver. Let's see if we can get breadth first search working. All right, so we're gonna do a solver here. We're gonna have a board B. Board, and then I guess we should have a position where we are, like position, and then we'll have this sort of step thing. And although maybe I'll do it without that position there, but I was thinking like my solver will get me my next state. All right. Let's see here. So we have a public. It's a 3-dimensional graph. So my board here. I'm gonna try and do something cheaty, right? I'm not gonna generate the whole maze ahead of time. Yeah. So really, we care about the position we're in, and then we want to see, can we move into one of our neighbor spots? And then if we can, then we try those, and we build the graph as we go. And since we're doing breadth first search, as soon as you find the exit, you're done. And I'm hoping I can get away with ignoring duplicate positions. Because the graph is changing over time. It's like a 3-dimensional graph. 3 Veggie pancit. Yeah, if you're doing it well, I'm gonna see if I can do it. You do it, you know, not well, and see if it works. So our solver is gonna return. What did my code even asking me to do at the end here? I don't even know if I read down to the end. What's the fewest number of minutes required? All right, so we're gonna do a public int. Solve. And so we have so there's like a certain number of time steps. The board's not rectangular, or the board is not square. I really wanted the board to be square so that'd be easy, but you could potentially set up like an int I and mod it by the cycle. So like the board eventually is going to have a cycle, but I'm too dumb to calculate that off the top of my head. So we're just gonna keep being dumb. We're gonna see if we can brute force it. We're gonna see if we brute force it, because as you said, topologist, we have a little bit of burnout here, and solving. I don't want to solve it. I don't want to do another graph solver. So we're gonna have a queue of position. So we're gonna do like a 2D, but keep track of the board changing, which will be interesting. That's solve is gonna just take in a board to solve board, and this really, I guess, could be a static method. All right, so we have a queue of positions. You think so, Chandu? I don't think it's going to be that hard. But we'll see if my head explodes. Next position. All right, G. Happy Christmas. Have a beautiful day. And I hope to see you this afternoon. I'll try not to explode. So the main difference with this one is that, all right, so if we really want to have a set of visited nodes, right? So maybe I will keep a set of visited nodes. I just feel like it's going to get giant. So public record state queue. Happy Saturday, my friend. We're doing our best not to freeze to death here. Gotta save some elves. We gotta save Christmas. We're almost there. So my state is gonna be a position P, and then I'm gonna be cheeky. I'm gonna be cheeky with my position here, and my next state is also gonna have a string board. All right. So and then I'm just gonna turn my state into a board, which is really dumb. But that should, if I've done it correctly, that should work. So we're gonna have a hash set of states visited equals new, and then we're gonna add in our new state from our current position. All right, so solve, we have to take in our starting position should be, what is it in the input? 0, row 0, column 1. Position start equals new position, row 0, column 1. And we're gonna add in our start and board dot toString. This is so dumb. And then our next position, we're gonna enqueue start. Okay. All right. All right. Let's do it. Well, our next position Yeah, the blizzard theme is on point for today. I'm very lucky. I'm in Arizona. No blizzard here, but it has been freezing. Which has been unfortunate. So while we have more things in our queue, we are gonna take out. Oh, we do need to keep. All right. Oh God. Oh. Oh, this is bad. This is bad. God, this is dumb, because when we go back in our queue, we need to use that previous. We need to remember what we were. But let's see, if we're doing breadth first search, the state should stay the same for that whole level. All right. Luckily, I've written my board as a. All right. I think I've been smart here. My board step returns a new board, so I think I've been smart. I think I'm okay. Yeah, it's been a nightmare for a lot of people, Stu. Stu, thank you so much for the follow. I just saw it. I appreciate that. We're in queue start. I'm aboard. All right, so we do need to keep track of it. Our state is gonna be a little. We don't. I don't want to write a hash for our board, a hash and an equal. So we're gonna just have our. We're gonna try here. So we DQ position P and board B equals next position dot DQ. All right, and then visit check neighbors. All right, so I need to add a neighbors to my position. Public position array neighbors like this, northeast, southwest. All right, so we're gonna get our neighbors. So neighbors, but we want to filter them out a little bit more too. Ends is equal to p dot neighbors where b dot inbounds p. So we only want to keep the ones that are inside of our bounds. And b dot is open p. So those are the valid positions. And we'll turn that back into an array in a second. So we got to add in this inbound and is open to our board. So public bool inbounds. We're inbounds if p is greater than or equal p dot row greater than or equal to 0, and p dot column is less than or is greater than or equal to 0, and p dot row is less than height, and p dot column is less than width. All right, so we're inbounds if that's true, and then we have is open position p if walls dot contains key is false. Walls dot contains. Walls is null here. It's not contained. Contains key. All right. So it's open if there's not a wall there. Okay. And the way, for anyone watching, my walls are defined as like contains a blizzard. Contains a blizzard. And I've defined the outside border as blizzards that don't move. So this should hopefully where bool this needs to go P goes to that. And I could also do b.inbounds.where b dot is open. This should also work, but this is slightly more inefficient. You generate more thunks with this filter like that. All right, so we have our position. These are our neighbors to consider. And then we'll do for each position and in neighbors. One other thing I'm missing here. All right, we only keep it where, all right, so ooh, we need to get our next board as well. Next board equals b.step. Because it's gonna, if the next board has a blizzard in that location, so it's actually not our current location, it's the board that comes after this one. We want to, yeah, it's the board that comes after this one. That's interesting. So I actually might want to put, or if I'm being intelligent, maybe, and this should potentially be the board that I want to check next. Anyway, all right, for my brain to be able to handle this, I'm gonna go ahead and not do that. This is the state. Get here, we return -1. It means we didn't find the exit. We actually are gonna say if P is equal to, oh, we have to like do a backtrack. Our exit. Position. Our exit's gonna be our board dot height -1 board dot column width -1 -2, I think, actually. Yeah. Okay. Oh, there's a lot to keep in my head, man. If this is equal to exit, we're done. So, you know, return something, return time step. We need to keep track of the number of time steps as well. I'm not, I guess I could keep track of that here, or my board here. Here, I'm gonna put it in my board. Public int time steps. get private set, and each time we call, this is going to start out at 0, and each time we step, time steps is going to increase by 1. All right. And I at least have it in my board. Oh, I'm feeling like I should have written some unit tests. I definitely should have written some unit tests, and now we're here in this little bit of a nightmare, and I'm out of coffee. I'm out of coffee. Forward position N in my neighbors. Yeah, this will work now. Because this will only have open spaces. Okay. And then I convert my board. We don't want to go to neighbors where visited.contains new state B and B dot toString. And so the state S equals, oh, I can't do that. I gotta do it here. All right, so this will only, where it doesn't contain it, keep ones where it is inbound, it is open, and we haven't been there before. All right, and then if we have been there, I'm gonna put this inside of my loop. So we have a state S equals this, and it's gonna be N, and then we're gonna say if N visited dot contains S, we continue. Okay. I'm gonna rename this lowercase v for good coding practices. Otherwise, we visit it and we add this to our queue. Next position dot add in queue our neighbor with the next board. And then this should return b dot time step. Oh God. Let's cross some fingers, man. So we're gonna do solver dot solve b int steps. We're on our, let's go to our example. Oh no, -1. Couldn't find a solution, so my exit might just be wrong. I'm hoping that's the case. Oh boy. Where's my right line? Where's this right line? In my example, should be -1 is fast. We can get there if we just go back in time. We were there yesterday, right? Okay, that is disappointing. But we can add in a little thing here that sort of is gonna tell us what we're gonna try. So I'm gonna add a little thing here just for us to say so we can like reason about it a little bit. So we're going to dequeue a thing, and we'll do a console.writeLine board dot, and I'm going to toString. We're going to add in a toString where we can give it a position, and it will do our toString with a position explorer. All right, so we're gonna have one with an explorer, and we will say else if p equals explorer b dot append e, so we can see where our explorer is. And this makes our toString be just toString with a new position somewhere out of bounds. All right, and so in our solver, we can display it with our explorer, and then we will put down over here Mike Cugs, thank you for the follow, I appreciate it. When we add these in, we'll put down which neighbors we're going to possibly explore next. Console.writeLine possible neighbor, possible choice is going to be our n, and after we display, here we go, where did I put it? Console.writeLine That's awesome. I'm so glad you're excited to learn how to code. I'm a teacher. I teach middle school, mostly middle school computer science and programming, but I also teach high schoolers quite a bit. And then I tutor some university level students. I tutor some high schoolers as well. That's awesome. 3D modeling is hard. 3D modeling is hard. Really cool that you're teaching yourself Unreal Engine. So I assume, are you teaching yourself C++? Unreal Engine, I think, uses C++, or there might be some other languages there. I've only tangentially checked out that. It's not bad, but it's tricky. So C++, there's a lot. C++ is an awesome language. There's nothing bad about learning it first. It's you have to manage your own memory. So there's parts of learning C++ first that's great. My first programming language was BASIC, but then after that I learned C. I didn't learn C++ until later, but I learned C pretty quickly. And but yeah, you don't have garbage collection in C++, and so you have to like manage memory explicitly. And I haven't done a ton of programming in C++ either. I've done quite a bit in C. Apollo, so nice to see you again. Happy Saturday. We're trying to debug my breadth first search here, which is going okay, I suppose. At position P, but yeah, you should definitely learn. I always encourage learning to code. Coding is so awesome. All right, and we'll stop at each iteration to check what we have in here. But I have a feeling that my exit is ill-defined, but we'll take a look. All right, so here's our map. Our possible choice is essentially to go down one. And we go down one, and our possible choices are 0, Oh, I should make it so we never go back up. That's an easy one. That's an easy one. Because yeah, we're gonna go back up and then it says we have nothing left to choose from there. That's interesting. Oh, you're right, Smab. We do need to be able to go back up there at some point. For some reason, it's not finding the this seems to be filtering too much. You're trying to do Monte Carlo. I love it. I love it, Smab. That's so good. That's so good. I am I'm baffled here with this oh, that feels all right. So how am I adding it to my queue and an NB? Should be go down 0 column 1 2 column 1. Oh, gotcha. Getting to the end point takes, okay, gotcha. So hopefully you find the best solution in so from here, I can't actually come back down because there was this guy going 1, 2, and on the third time it'll be there. So there's no possible positions to go to, and for some reason it's also saying that for this one there are no places to go. Oh, I can wait. I can stay. Okay. All right. My bug is that I'm assuming I have to move, but you can actually wait in a position. So in addition to my neighbors, I need to, all right, let's make this a list. And then I can wait in that spot. ns.add p. Oh, which isn't quite right. .to list ns.add p and then ns equals ns where. Okay. I wasn't waiting. All right, so you have to wait sometimes. Oops, that's not what I wanted to do. Well, still not waiting. Inbounds now. Okay, inbounds. We actually, okay. Everything was less than height. Hang on. I'm just dumb. Misreading. This is my same position. So we can move down. We can also have waited. Okay. All right. I think I have. Let us. Really need to add in a. I should be using a logger so I can turn it on and off, so I don't have to do this. Over on YouTube, This Old Stoner, do you have a beautiful day as well? Thanks for hanging out. Thank you for hanging out. It's always a pleasure. It's always a pleasure. 18, all right, that gives me some confidence that we're gonna be okay. Are we gonna be able to get some coffee here? Oh no. Oh. 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 El Pica. Hope I'm pronouncing that right. Thank you for the follow. Hope you're enjoying it. Sorry for the delay in seeing that you had clicked that follow button. Let us feel like my state here might be causing us issues. I'm gonna do public int depth is equal to 0. Each time we reach another depth, I'm gonna put down how far we've gone. So if b dot time steps is greater than depth, public static, I guess I should just do int depth equals 0. Right, greater than depth, console dot write line at depth depth equals b dot time steps, and then we'll also report visited dot count. Good luck. I'm feeling very... All right. You know, so mine is actually working quite well. The issue is, I think my two string here, I think, is really slowing things down. So I'm gonna try something a little bit different. I'm actually curious if I get rid of this visited, my depth will actually grow faster. Oh wow, that's actually worse. It does solve the example properly. Yeah, so I did get the example working. It's just a question of how much time. So this is the number of like time steps I've examined. Depth is like 64 seconds. So I do suspect that if I were to leave this running, I would get there. I'm just surprised that it gets so slow here. All right, I might just leave this running to see if I get it. But I feel like Chandu, that's an excellent question. I just love teaching. Uh, I've worked as a software engineer in the past. Um, what I will say is, working as a software engineer, you can make a lot more money than as a teacher, but I get a lot of gratification from teaching. I think I'm pretty good at it. Um, no worries. I think I'm pretty good at teaching is the other thing. Uh, and oh, when I was learning computer science at university, I just felt like most of the teachers were not great. I had some awesome teachers, but they weren't great, and I just felt like I could do better. And I was a tutor. When I was in undergrad, I became a tutor for computer science. I've always wanted to be a teacher, actually. I went to school originally to be a music teacher. I have a degree in music education. Um, that just wasn't for me. And then computer science, always been a programmer. I've loved programming pretty much my whole life. Um, yeah, so I've loved programming. This is sad how long this is taking, but excellent question. I enjoy it. The real answer is I enjoy it. This is never gonna finish, is it? Oh, I'm so sad. My queue must be massive. Um, I'm curious if I'm ending up repeating things. I might need to switch to doing A star. So this is breadth first search. A star might be a much better search. I was trying to avoid generating the entire graph, but maybe I need to just generate the entire graph and then do an A star search on it. Well, I know it's just big. So, oh, I know how to do it. I just don't want to stop because I'm going, oh, well, if I get, I I have, what is the fallacy there? It's like, oh, well, maybe, if my depth. Oh, I can attach it to a currently running program. It does. All right. Chandu, talk me through it. Stu, I'd probably just I don't know exactly what they would be, but I would favor going south and east. Right? So going south and east, you're like making progress. If you go backwards, it's not guaranteed to get to there, but I bet you could get pretty close and then, fiddle around with it a little bit. It's a great question. Debugger and select attach from the drop down menu. So I'm running it you know what it is? I'm running it in my terminal. I didn't click run without debugging. So I'm not actually running it in VS Code. I'm running it from my terminal. My thought here is that I should be able to just calculate my cycle for my I didn't think the graph would be so giant. I'm confident that this will eventually give me the right solution. But I should probably just do better. I should really go back and generate my graph. Orsted, thank you for the follow. I appreciate it. I hope you're enjoying the stream here. I am feeling some admin of code burnout. And really not feeling like optimizing this. Oh, you know what it is? This does not work. This string here, I'm dumb. This string does not work. Because if I have overlapping, oh, I'm so dumb. This is not correct. Because if I have overlapping nodes, they display a number, not the direction of travel. So this doesn't work. And I do need to, I guess, define a better state here. Really, there's a cycle. I need to calculate the cycle, how often this program loops. You know, so cycle is what I need to figure out. And for some reason, my brain, I was hoping I didn't have to figure out the cycle. And so it's gonna be nb.timeSteps mod, you know, max cycle. I was trying to be cheeky to get away with it. So I need to figure out what my max cycle is, and it's basically based off like the width and height of my board. So like the bad way to do it would be int board dot max cycle. It's like the lowest it's like the greatest common denominator. Smab, that's how I'm feeling. I'm like, oh, I'm gonna have to work out an actual algorithm, aren't I? So board dot width what does my cycle look like here? Probably Q. Probably. I'm feeling slightly demoralized here. Been going for almost 2 hours and I gotta stop here in about 6 minutes, and I'm really sad that I didn't finish this. It's definitely wrong, and I feel like I'll get it. I just have to be smarter about. So I'm actually thinking maybe I generate the whole graph. I was trying not to generate the whole graph, so it'd be big. And this isn't right either. This should be like -2. Console.WriteLine max cycle. Yeah, there's a smaller cycle than this though. Oh wow. Is that can't be right. Oh. Calling toString over and over was definitely bad. 3,000. So I have to get to 3,000 time step to identify that one. I don't think this is going to be helpful. Oh man. My toString was really slow, but this is still bad. Oh, my bandwidth's probably just slow, so you guys are on a minor delay. All right, so I want to find the greatest, what is it? The greatest common denominator? Is that right? So my two string was definitely a slow thing in there, calculating that at every step. I wish my board think my board or lowest common multiple. Is it lowest common multiple? It's one of those two. I just have to do something. Yeah, I'd have to think about it a little bit more. Like I know like the direction I sort of need to move, but not exactly what to do. I think I'm gonna there's definitely some really bad computation here too. I'm spending a lot of time building this up over and over and over. So I could do. There's some really good optimizations I could do here that I guess I'm gonna have to come back and do later. I'm unfortunately out of time. I'm out of time here, which makes me really sad. All right, but let me tell you what. Thank you everyone so much for hanging out with me. This has been super fun. I'll be streaming tomorrow as well. Tomorrow morning, Advent of Code, day 25, last day. I'm gonna come back, try and finish this later this afternoon. I do. Gotcha. Yeah, I wasn't sure if A-Star would actually work or not. But I'm gonna hop off here. I usually stream in the afternoons as well. In the afternoons, I work on I'm gonna be working on a project, my Space Raiders project. I don't know exactly when that is. It's usually about 3 p.m. my time, but it's not on my schedule. But have a beautiful day, everyone. If you want to know when I'm coming back, feel free to follow so you get that notification. But have a beautiful day. Keep learning, keep growing, keep coding, and you're welcome back anytime. Thanks for hanging out.
Hey, how's everyone doing? What were you guys doing on your stream over there? How was it? Happy Saturday to you too. Tip of the hat, whatever. Anyways, for an introduction, I'm doing Advent of Code Day 23. In general, what we're trying to do is, what we've been trying to do for the last month is we're doing Advent of Cool. My God, I need to find my repo. Oh no, I'm embarrassing myself in front of all these cool new friends. So this is the repo. We've been trying out a different language every day, basically. And we were attempting day 24.
Hello, motherfucker.
Nice. Hey, thank you for the follow, Captain Coda. Welcome to the gang. So we've been trying out different things, and today we're working on Scala. As the title may have suggested, or to be more accurate, we are struggling with Scala because I'm very new to this. Hey, thank you for the sub. Holy shit. Thank you for the gifted sub. Hey, Slippy. Oh, by the way, I added some new emotes. Some of them are not done yet, but as in some of them are. I'll just put them out here. There's this. Just one second. Let me just bring all of them out. Edible. All of these. There's a couple more that are not approved yet. Oh my God. Whew. This is a momentous occasion. Let's celebrate. Awesome. My brute force for day 24 just finished running.